Hello everyone, this is George, and in this lecture we'll be talking about conditional statements. Now, before we start, I have to warn you, this is a recording made in 2013, that's the year 2013, so why do we do this, and why did we put this video in the playlist from 2012? Well, we had fundamentals course back then, and this video, conditional statements, along with the loops video, got, well, not recorded well, so we're doing it again, and I'm recording from home, so there's no audience, and you have to excuse any ambient sounds that you may be hearing, you know, someone walking in or something like that. So let's begin with the matter at hand. Conditional statements. We're going to discuss a few things, starting with comparison and logical operators. That is things we have already discussed in previous videos, the videos on operators and expressions. Then we're going to continue with the if statement. We'll say what that thing is, what a conditional statement is in its nature, how does it function. Then we're going to continue with the if-else statement, nesting if statements, and using a switch case to reduce the number of if-else statements we need. So up until now, if you haven't been doing any programming before that, we've been doing our programs like this line of code, then that line of code, and so on and so on. And this was always straightforward, and we didn't check any conditions or anything like that. So now what we're going to do is learn how to branch our programs into several different branches. Yeah, branch into branches. So here's our program flow, our control flow, or however you want to call it. And here we have the if statement. We'll discuss what that is and how it functions, but let's say we just have an if statement over there, and it branches our code into two sections. That is, actually this would be more like an if-else statement. Okay, let's start again. Here's our code. Then we have an if statement, and if the condition in that statement is true, well, then we execute some other lines of code. If it isn't true, we just continue with the lines of code past the if statement, and our two branches join up together lower in the diagram. So, for example, what's an if-else statement? What's an if statement at all? Well, that's a way to tell your program to pick a different course of action when some conditions are met. And now we're going to see how we can check for those conditions by seeing the comparison and logical operators. So in programming, as you already know, every action is done by some operator, be it summing, the dividing, multiplication, or whatever. So what we have here, when we're using if statements, which we'll see in a few moments, we have the equals operator, we have the differs operator, that is not equals, greater than, less than, and all of those which you see on the screen now. So what do we do with these operators? Well, as you already know, they return Boolean results, that is, results which have the bool data type. So for example, we can check if the number 5 is less than or equal to the number 6, and as you've already guessed it, this is a Boolean expression which gives us a Boolean answer, which is either true or false, and in this case we have the answer true. So result in this case is true. Now, why do we repeat this, since we've already discussed it? Well, because these logical operators, including these ones which you see right now, the logical NOT, the logical AND, the OR and XOR, that's exclusive OR, will be used in our conditional statements to check for some conditions. Now, here are some De Morgan rules De Morgan laws, you don't really need to remember this stuff. You'll learn to understand logical operators without knowing these rules, but let's just discuss them for a while. So the not operator means give me a result which is opposite of that which we already have. So true is going to turn into false, and false is going to turn into true. So if we have twice of not, we're going to get the same answer as we got. For example, if we have say true here, and not true will be false, and not true will be again true. So that's why we have not A will give us A. And you can have similar logic for all these over here. You can write them down, you can check if these lines are correct, but I assure you they are. You won't need to do this when you're trying to program. Those things will probably come in naturally, and you'll understand what you have to do naturally. For example, when you have to check, is it raining outside? Yes or no. So that's a simple Boolean check. Or if it's raining outside and at the same time I don't have a raincoat, then I won't go outside, for example. Well, that's an example of a logical statement which consists of two parts. The first part having is it raining, and the second part having do I have a rain jacket or an umbrella. What I said 1 minute ago was if I don't have both of them, then I don't go out. So that's an example of a statement which uses logical AND. So for example, if it is raining and this thing is true, and at the same time with the AND operator we have no umbrella, then in this case, if both of these are true, then we'll probably stay at home. In the other case, we'll do something else. So you see these rules and these checks. You don't have to remember any complicated math or anything like that, or you don't have to learn these things by heart. All you have to do is think logically, think how you have to compose your program flow, and everything will be okay. So some actual examples and getting to the subject at hand, if and if else conditional logic. As I said, the if statement is something which gives you the opportunity to execute specific code in specific situations. So how does an if statement look? I won't discuss this theory that much. I know you're more of the people which would like examples. So how do if statements work? Well, you have the keyword if. That's a standard C# keyword. It's also a keyword used in many other languages. For example, C++, JavaScript, Java, and pretty much everything else you can think of. So here's how the if statement looks in C-like languages. We have if, the keyword, and then in brackets, normal brackets, we have some condition. Now this condition is a Boolean expression of some sort. It could be one variable, it could be an entire expression like you saw me write a few seconds ago. It could be anything which returns a Boolean result. Those of you who are ahead with material, they know that this condition can also be a Boolean method or something else. So conditions do the following thing. They check for some sort of situation. For example, if you are larger than 5 years old, you can do something. For example, you can visit the playground. I don't know why I said playground for 5-year-old children, not less, but that's some example. If you're, okay, something more of your type, if your age is larger than 18 years old, in most countries, you will probably drink. Well, some people drink even if they don't have 18 years of age, but that's a whole other question. So, now we'll discuss this in detail. So, the if statement checks the condition, that is, it evaluates this expression, gets a Boolean result, and if the result is true, it goes into these lines of code. Now, notice these brackets. These brackets are carry the name of the body of this if statement. You see many other things that have bodies in C#, along with the passing of the course, but this body is the set of statements which will be executed sequentially to respond to some condition expressed here. So, if this thing is true, then the control flow goes to this body. These statements get executed, and then the control flow returns to the normal part of the code, everything which is after the if statement. In the other case, when we don't have true in this condition, for example, we have false, what happens? Well, the computer just skips everything in this body, skips that, and goes on with the normal flow of the program. So, nothing too complicated. If you have true, you execute the statements. If you don't have true, you continue without executing the statements. So, basically, the if operator says, only if this condition, and in no other circumstances, only if this condition is true, then execute these statements. Okay, so now what can we do with this if statement? Well, as I told you, this statement can contain a condition which can be both a Boolean variable, a Boolean logical expression, some comparison, anything. What you can't have in C# is a condition which is an integer variable. In languages like C and C++, and JavaScript and other things like that, you can use basically any variable which you can use in other places to have it as a condition in an if statement. Well, that's not the case with C#, and there's a good reason for that, mainly because if you could do this, if you could use an integer variable or something else, it's very easy to make a mistake. I'll give you an example of that later on. So, basically in computer science, what is true? Well, true, the value true, is any piece of memory which contains at least one bit set to 1. So, that is, for example, if you have integers, if you have the number -5, which looks like, okay, -1, that will be easier to calculate. So -1 in a, for example, byte variable, as byte, signed byte variable, will look like this: 1, 1, 1, 1, 1, 1, 1, and how many did we get here? 4, 6, 7, and without the last one. So I might be mistaken right now, but this should be the number 1. So yeah, I'm probably mistaken, doesn't matter. This should be the number 1. So this has ones in its binary representation. So the number -1 will be evaluated as true in other programming languages. The number, for example, 23 will also be evaluated as true. The number 4 will also be evaluated as true, and anything else will be evaluated as true, except for the number 0. The number 0 has, oh yeah, forgot to turn off Skype. Great. So the number 0 is always evaluated as false, because 0 in any sort of representation has only 0 bits in it, no ones, no 2, no nothing. Any other sequence of bits which has some bit set to 1 in it is evaluated as true in other programming languages. Now this could cause a lot of headaches, and that's why it's removed from C#. So, as I said, what you need to remember is you can have Boolean anything. As long as it's Boolean, you can use it for a condition in the if statement. Then, how can you construct the rest of the if statement? Well, first option, you can have a single statement with a semicolon ending it. As you know, every operation in C# should be completed with a semicolon after it. Well, you can use an if statement like this. You have, for example, if some condition, let's say it's Boolean, and then, for example, increase this variable. And that's a valid if statement. So if the condition which is written down here is true, so if this thing is true, then we will execute A++ and continue on with the normal execution of the code. If this thing is false, what will happen is we'll just skip this A++ and go on with the rest of our code. Okay, so the other thing you can do is use a block, a body, which is enclosed in braces, and not braces, brackets. So, for example, you can have if some condition, and as you saw in the theoretical example, we have these curly brackets. Then we have some code, for example, A++, B++, and so on, some other statements, and then we finish with the closing bracket. Now, this is required when you want to execute more than one statement. For example, here we have 2 statements, or even more. In the previous example, we only had an if statement with some condition and one statement. Now, here's how things work. If you have a single statement, the if operator will take it as part of its body. So you can imagine that the if operator puts an imaginary bracket in front and behind of your operation if it's single. Now, why you shouldn't use this type of spelling, this type of syntax? Well, it's very easy to make mistakes. So, for example, if I write if some condition and write A++, okay, that will work. Say, for example, that 10 minutes later I decide that, oh wait, I need some more code. For example, I need to make a B minus minus, for example, and I write it down here or on the other line, or doesn't matter where I write it. Well, that will cause us significant problems, because actually what is enclosed in the brackets, yeah, you guessed it, is A++, and B minus minus stays outside. Guess what will happen? Well, no matter whether this thing here is false or true, both cases will lead to the execution of the B minus minus statement. So as you can see, this is a problem, because we think that we've made, so true will go through A++ and then will go to B minus minus, and false will only go to B minus minus. So that could confuse you. Not that the compiler won't understand it, but it probably won't understand it the way you want. So it will compile, but it will compile something which you don't want to achieve. So always use curly brackets after an if statement. Always enclose its body with curly brackets, even if it's only one operation, even if it's only A++. That way you'll be certain, even if we have something like this, then A++, well, use the curly brackets. Always use them. Don't skip using curly brackets. You won't run out of ink on your PC, I guarantee that. So always use curly brackets, and this formatting is better than the one I wrote a few seconds before. Always use them, because in other cases you might end up being in some situation like this one over here, where you're wondering why your code doesn't work after you've written something that seems correct. So always use this syntax. I don't know how many times I'm going to repeat it in this lecture. I bet it will be a lot, but always use it. It comes from experience, from people who've written code a lot of times before, so trust them. If you don't trust me, trust them. If you don't trust me or them, well, you're going to end up in some pickle where you will wish that you had listened, and you will waste basically half an hour looking for a problem which isn't really there. Okay, so this is the curly brackets. Always use them. That's the last time I'm going to say it for the next 30 seconds. So they enclose all the statements you wish. You can enter how many you want. You want to write 10, write 10 statements. You want to write 15, you write 15 statements. You want to write anything, you write it inside here. So if you want, for example, to write initialization of variables, you can do it here. If you want to increment variables, like you do it here, well, you do it here. If you want to put another if statement, well, again, you can do it here. If you want to put in loops, method calls, or anything you wish, reading from the console or catching exceptions, or whatever you want, you can put it right over here. You can put everything here, everything you can think of, which can stay in your normal execution code, can stay in an if statement. We'll get to that a little bit later on. So, here's how things go. We have a condition over here. This is the if statement. For example, this would be written down as if condition. And if the condition is true, we execute these statements down here. So this is the body of our if statement. And then goes the normal program code. If the result is false, if the condition is false, well, what you get is you skip these curly brackets and continue on with that normal execution of the code. Basically what's said down here. So this is the flow chart of how an if statement works, and I guess you've probably deciphered that by now. Okay, now some practical examples. Say we want to enter two numbers and we want to get the bigger out of them. Well, here's what we have here. Here's our main method, nothing out of the ordinary. Then we do an parsing of the console string which we get. So we do a console read line and then parse that console read line. As you already know, int.parse takes a string which console read line returns, takes this string and turns it into a number if it can. So we basically read two numbers, bigger number and smaller number, and we decide that the first number is going to be bigger, and we're going to check if that is wrong, and if it is wrong, we are going to correct it. So how does this thing work? Well, we have an if statement past the input, so this is the input, and this is an if statement which checks whether the smaller number is actually bigger than the bigger number. So these should basically be named first number and then second number, but that doesn't matter right now. So if we have the smaller number being bigger than the bigger number, which we shouldn't have, but if we have it, if this condition is true, then we're going to go into this line of code which says, okay, fix my mistake and make the bigger number equal to the smaller number. And since we're only going to print out the bigger number, we aren't really interested in saving the value of the smaller number right now. So we say just bigger number, get the value of the smaller number, and we just write it down on the console. If this condition isn't true, if this thing is false, then we will just continue, and in that case what? Well, we will have the bigger number with the bigger value, because this condition hasn't evaluated to true. If it hasn't evaluated to true, then our initial assumption is correct. So this is how the if statement checks for a certain condition and adapts the state of our program to that condition. In this case, we adapt this part of the state of the program to its correct value when this condition is met, when the condition that we have basically misnamed our numbers is right. And then we print out our number with a standard formatting string. You see the greater number is, and then put here the first variable after the comma, which is the first variable, bigger number is the first variable. Okay, so that's an example of the if statement. Now we will see it in action. we have a Visual Studio example. I'm going to make this a bit larger so you can see better. Enter two numbers. Here we go, first number and second number. This is somewhat better naming. So we enter the first number and we enter the second number. So if the bigger number which we entered equals, sorry, that's wrong. Oh, come on, I want to get this thing out of here. Okay, so we say the bigger number will be equal to the first number. That's our assumption. If our assumption is wrong, that is, if the second number is bigger than the first number, then the bigger number should become equal to the second number. So we make an additional variable which takes a number and takes the first number, and if our assumption was wrong, well, then we do our correction of our state of our program, which is assign the value of the second one to bigger number and then print the bigger of those. So what will happen? Well, if we have our first number bigger than the second number, if this condition is false, this isn't met, well, the code will just skip this if statement and continue on. Actually, it will skip this body of the if statement and carry on after checking this, if this thing is false. Okay, so in the other case where this thing is true, where second number is larger than first number, well, we will get into this body, execute this line of code, and then continue on, and then print out. Okay, let's see this in action. We start our program, Control F5 does that for us. Enter two numbers on separate lines. That's our first line of code, which says console write line, please enter two numbers. Okay, so here's our numbers, the number 1 and the number 2. And it says the bigger number is 2. What happened? Well, we entered the first number, it was smaller. First we set it to bigger number. It was smaller, so this was executed. Bigger number became the second number, and just continued the code. Okay, let's enter another number. For example, we have 10 as our first number, and then have 2 as our second number. Well, what we get here is, we get the number 10 as our first number. We say bigger number equals first number, so bigger number becomes 10. And then we say, well, if we made a mistake and second number is actually bigger than first number, which isn't the case, then execute these lines. But because this thing is false, we will just skip these lines and continue on. And bigger number will stay with the value of first number here. So we have this code executed, and we print out the proper number. I suppose you've probably understood it. I can't really say because I can't really see you right now, the people who are watching this video, but you can watch it again and try again and experiment a bit for yourselves, and you'll see how this thing works. It's fairly straightforward, so we won't give it too much time. So that was the if statement. Now the if else statement. If else gives you the opportunity to execute one line of code, and if that line of code is for the condition where it's true, you can have another line of code which is for the false condition. I know that sounded a bit weird, so I'm going to explain it with examples. Now, you have an if statement with an expression, things you already know by now. So, if this thing is true, then we go into this line of code. If this thing is false, another color, if this thing is false, well, then we go to the code in the else statement. Nothing too complicated. So, true, go into the if, false, go into the else. What's the difference? Well, before we just had, when it was false, we just skipped the body. Here we skip the if body, but we go into the else body. That gives us the opportunity to have different operations in two cases of our condition. So if our condition is met, do something. If our condition isn't met, do something else. That's the point of having if-else statements. So for example, we can have if it is raining, and this thing evaluates to true. So if it's raining and this is true, then execute statement 1, which will be stay home and watch TV, or whatever you guys do in your free time at home. So stay home and watch TV. And if it isn't raining, so if we have false over here, then we go to the other statement, which is go outside and play ball like a dog. So go outside and play ball. We have two different things we can do in two different cases of our condition. So this can only be true or false, and in each case we can do different things. So we can tie up if-else statements like that for a lot of condition checking if we want to, and we'll see that in a minute. So this is the simplest form of an if-else statement you can imagine. There's a more complicated one which checks more conditions, but we'll see it in a moment. So this is if-else. How does it work? Well, basically the same thing we had with the if statement, with that difference that we have a condition here, and when the condition is false, when it isn't met, we have a second statement which we execute before going back to the code. So we have some code that executes if the condition isn't met. For example, if the user input rightly formatted data, well, then we're all good to go, and we can continue. We can, for example, parse that data and continue on with the normal control flow. But if the user didn't input correctly formatted input, then we, for example, print out user, please give me correct input because your input is wrong and you're a noob. So that's the if-else statement. So if the if-else is true, so if the if condition is true, if I write it, it will be easier. If the condition is true, then execute this thing, these lines of code. If it isn't true, execute those lines of code. So else, not L or whatever I wrote there, else execute these lines of code. So that's basically it. That's basically our if-else condition, if-else statement, sorry. So, some example. We read a number from the console and we want to check if that number is odd or even. What do? Well, we basically read the number, parse it as an integer, and then check. So how do we check if a number is odd or even? Well, all even numbers divide by 2 with a remainder of 0. So we can use the division with remainder operator. So this will give us the remainder of the division of number by 2. And we check if that remainder is exactly equal to 0. And if that is the case, we just write on the console, well, the number is obviously even. In the other case, we say, well, if this condition isn't met, which basically means if number divided with a remainder by 2 gives a remainder of 1, because that's the only other case, or basically set in a different way, we can say if number has a remainder of different than 0, then execute this code. So I can write this thing in a million other ways, but this is the easiest way to do it and easiest way to remember it. So we just check our condition. As you see, we have an integer operation over here. But then we have a comparison operation, which makes our integer expression here and integer expression here aggregate into a Boolean expression. So basically, because we have a check operator, check if it's equals, then we basically have a Boolean condition in this whole expression. So if this condition is true, again, do this code. If it isn't true, do the other code. Okay. So we have an example here, going to Visual Studio and opening the if-else statement. Here's our if-else statement, nothing too complicated. If the number divides by 2 with no remainder, then we write that it is even. In the other case, we just write that the number is odd. That's it. Okay, let's check this thing in action. We start our program. Did I just... No, I didn't. Okay. We start our program. What happens here? I'm starting the previous program. I even closed my code. So opening this again. Now, right now, this isn't the active project, and you can get fooled by that sometimes. If I, for example, stare at this code and start it, I will see that it says enter 2 numbers, but this code says something else. Well, when you see something like that happening, you're basically not executing the correct project. So you go here on the project file, that's this thing over here, and you say right click and go to set as startup project over here, this thing. So right click, set as startup project, you see it getting bold, that's what you want to happen, and then we can execute it, and it says please enter a number, what we wanted to do. So enter a number, I enter 14, and it says this number is even. Why? Because number divided, the remainder of number divided by 2 is 0. So this condition is met, and we write this code. In the other case, when this condition isn't met, we execute the else code. So we say else this number is odd. Nothing too complicated, nothing out of the ordinary. Okay, we can do a few debugging steps if you want to. So I'll just put in some debug points, some breakpoints here, here, and here. Okay, so now I'm going to say start. Okay, not like that. Start debugging from the debug menu over here. You can see F5. I was using Control F5 up until now. So start debugging. I'm going to get my console now. Please give me my console now. Okay, thanks. So here's my console, and I write down, for example, 3. Then we get in this line of code, number is 3, we try to divide it by 2. Oh, it even gives me the result. You can see over here, no, you can't see. Now you won't see. You won't see. This thing fades out when I zoom it in. But you're watching actually a video, so you can pause it and see it. So it gives me the answer that number divided by 2, its remainder is 1. That's integer division, not standard division of floating numbers. That is integer division, and integer division by 2 gives us a remainder of 1 in exactly this case. So because this condition is not met, we have this is 1, this thing is 1, as you can see, as you can see, our compiler told us a bit earlier. So because this thing is 1, this condition isn't met. So now we will skip to this breakpoint. We won't hit this. We won't get here. That yellow arrow won't get there. It will go lower. It will go here. And now you're going to see it. We say continue. That's where it went. Exactly at this point. And this should write on the console, this number is odd. Now, note that it hasn't wrote it just yet. We have basically, the breakpoint works before the first operation on the corresponding line. So basically, we've stopped the code over here, not over here. We've stopped the code here. So now, when I hit continue again, this will output this number is odd thing on the console, and it just closed my console. That's how debugging works in Visual Studio. It basically closes your console as soon as the program finishes. There's a multitude of ways to stop it from doing that. The easiest but not so correct way to do it is just do a console.readline at the end, and now we will start it again, and we'll again input the number 3. We break here, say continue, we're on this line, still nothing written on the console. Say continue again, and this thing you see says this number is odd, so it basically output this string. Now we have a console read line over here. If I say pause, look at where our marker stays. Our marker is over here. So this is what's being executed at the moment, and that's why the program hasn't finished. Be really careful if you're going to use this sort of approach, because in some competition systems or in a lot of other places, an unneeded console read line would probably mean that, oh, your program is waiting for more input and nothing happens. So don't do this if you're not going to be careful. Always be careful when you do such stuff. Okay, so that's our code. That's our if-else statement. Hope you understood it. Nothing too complicated. If one condition is met, well, we execute the code corresponding to that condition. In the other case, we execute some other code. Continuing on with the lecture. Nesting if-else statements. Now, you can guess that in some cases you will need more than one level of processing of information. For example, you will need to check if a number is less than 0 or bigger than 0. Then you need to check if the number, if it is bigger than 0, is it, for example, an even or odd number. So that's more if-else statements in one place. How do you do that? Well, you basically nest if-else statements one in another. As I already said, you can put anything in the body of an if statement, anything in the body of an else statement. That includes other if or else statements. Anybody watch Genesis? Well, you can watch it now. That's basically what you can do. If some condition is met, and another condition is met, and another condition is met, and after this processing another condition is met, you can do something. On the other hand, you can do other stuff. So let's see how this thing works. Here's our initial, our top level if-else statement, if and then else. Oh, by the way, something I forgot to say. Else statements also can have brackets or not have brackets, but the important thing is, same as the if expression, that when you put in brackets you can put multiple statements. Again, what is recommended is that you always use brackets at else statements also, not only at if statements but also at else statements, in every particular case which you might meet, every time. Only one exception for the else statement, and that is the else if construction, but we'll take a look at that a little bit further on. So what we have here is a Boolean expression for our if statement, and if this expression is true, we go into this code. Okay, what does this code consist of? Well, for example, we're searching for input. For example, we have the task get a number from the console, and if number positive, and if the number is positive and even, print out I am happy. I don't know why you could be happy for a positive even number. Maybe because you can share it with two people, doesn't matter. But say that you have this task, and in every other case, else print out, for example. Okay, so and if the case is that if it is even but odd, print even odd. And if it is negative, just print damn. Okay, so for example, you have this task. How are you going to realize it? How are you going to implement this behavior? Well, you input some number from the console. Say we have this code that inputs a number from the console, and we check if the number n, for example, is larger than 0, because positive numbers are larger than 0, and 0 is neither positive nor negative. That's math, you don't need to know about that. But say if we have n larger than 0, and if n, yeah, you guessed it, divides with no remainder by 2, dividing by 2 equals 0, remainder at division by 2, I don't really know how I should say that in English, so I'm saying it like a dope. I hope you understand what I mean. So, and this operator 2 equals 0. So if this is met, we print out over here that, yay, I'm happy. I'm happy. Yeah, I know that I'm is written with the capital I, but I'm too lazy to do it now. So I'm happy over here, and if it isn't divisible by 2 with no remainder, then we have to print out even odd. That's a piece of bull, yeah, you know. I meant positive odd over here, not even odd. That would be stupid. Okay, so I bet some people are going to rage in the comments. Oh, you dope, you shouldn't do that. Okay, so positive odd, well, we want to output it over here, positive odd. And in all other cases, we just want to print out damn. Okay, so that's how our code would probably look like. It's a big mess, but now we'll see it in action. So basically this is how if-else expressions work. So you have that's how nested if-else expressions work. So you have ifs, and you can have other if-elses in them, and elses, and you can even have other elses in here also. We'll see that in a moment. So some good practices while we're talking about nested ifs: always use brackets in absolutely every case. Nested if-else statements are very dangerous when you don't use brackets, because things could be ambiguous. So you could make a mistake. What will happen? You could write something, think that it will work in a certain way, and it works in a totally different way. So always use brackets so as to be sure which will be executed when. Some other things like using more than 3 levels of if statements. Now, up until now we haven't really learned about methods and loops and things like that. We'll learn about loops later on, but up until now don't consider this rule too much, because you will have exercises in which you will need to use more than 3 levels. It's not a good practice to use them, but up until now you haven't learned how to avoid them. So this don't consider it that much. Normally put the case that you expect to process first. Well, that's kind of logical, you know. If you're expecting, for example, always odd numbers, well, put their processing first, because that will lower the amount of operations which the computer has to do every time. So if you have 80% of your input probably odd numbers, well, you won't have to check the other thing if they are, for example, even. I'm not sure if you understood my example, but the idea is always put what you expect the most at the top in your code. It would make it more readable in any way, and it will make it a bit faster in some cases. Always arrange the code, always put indentation, always put brackets and things like that. Always use the same style. Now some people would use brackets like this. We have if, we have a condition, and we have a bracket opening over here. Now this isn't a correct C# style. This is something which you will see in Java. Java programmers use that. Well, in Java, okay, so you know, if you don't bathe often, if you don't have a bath often, people won't like you. In C#, if you don't put the brackets on the lower line, people which write C# won't like you. Not that I'm saying that Java people don't have baths often. That's not what I meant. So when you write in a certain programming language, be sure to keep the guidelines of writing code and formatting code. Be sure to keep the guidelines in your code. So follow those guidelines, not keep the guidelines, follow those guidelines, because that will make it easier for you to read other people's code, and it will make other people's code much more understandable to you, because you will get used to the style of writing. Don't rape the language with bad styles of writing. It will make it difficult for you and other people which will read your code. So arrange the code. The proper way to arrange brackets and if-else statements in C# is the following. You have if, you have a condition, you have an opening bracket on the next line, then you have statements, and I don't have any space, but the closing bracket is on the line after all the statements, so on a separate line after the statements. So it's over here somewhere, I can't show you right now. Okay, so always keep these things. Here's an example of some processing with nested if-else statements. We have a conditional which checks, we say we have three numbers, that's first, second, and third. So first, second, and third, and we have a check between first and second. What we want to do is check, so I'm speaking wrong stuff right now. We have only two numbers, not three numbers. We have first and we have second, and we want to know which of the two numbers is bigger. Not get the value of the bigger number like we did in the first example, but check which one of those two input from the console is the bigger number. So if the numbers are equal, we just say, well, they are equal, obviously. In all other cases, that means when the numbers are not equal, when this is false, well, check if the first number is larger than the second number, and if this is true, well, output on the console, the first number is bigger, because this expression leads to true, if this is true. If this is false, so if this thing is not true, if second is larger than first, well, go into the else statement. Now, why do we need nested if-else statements here? Well, basically because we have the option of the numbers being equal, and only if they're not equal, when this is not true, then we can check if one of them is bigger than the other. Sorry about that. So that's an example of how you can use nested if-else statements, and here's a demo of that same thing, nested if, and here's what we have here. By the way, Alt, Shift, and Enter puts your code into full screen mode. Okay, so that was Alt, Shift, Enter. So we have entering of two numbers, first number, second number. Then we check if those numbers are equal, and if they are, we print that out on the console. In all other cases, meaning when this is false, go to these two statements which say first is larger than second. Well, print out that first is larger than second, and in the other case, print out second is larger than first. That's basically what you have here. Okay, so execute this. Now, guess what we have here? We didn't set this project as a startup project. Now, if you don't want to do this every single time, you can go here to Properties and pick. You first have to wait for Visual Studio. Thanks, Visual Studio, and you pick here Current Selection. So that was, and you say Apply. That was Solution, Properties, and Current Selection. That will make your currently selected project, like for example if I click here, it will make it as if I said right click, set as startup project, just with one click. Okay, so for example 6 multiple labels, click here and it sets it as a startup project. So we have nested if else here, open it, you have the code, start it, I mean you saw the code, not you have the code. Two numbers, 12 and 13, and it says the second number is greater. How did it do that? Well, let's see in debug mode. We put some breakpoints, for example, here, no, not here, here in the checking, and then here in this if-else statement in its body, and here in the else. Okay, so start this thing in debug mode. Write two numbers on separate lines. Okay, 14 and 15, for example. First is 14, second is 15. The result of this comparison is a Boolean variable which has a value of, yeah, you guessed it, false. And because this is false, we skip on to these statements over here. Now I will put a breakpoint over here so you can just see it. Press continue. This goes right into the else statement. It didn't go over here. I won't show you that, but it didn't go over here. So going inside the else statement, we have an if statement which checks the first condition, which is 14 larger than 15? Well, obviously it isn't, so the result of this is also false, and this line of code won't be executed, and we'll skip on to, yeah, you guessed it, the else statement. When we press continue, here's where we got. Now, right now we're at this part of the code, and the next thing that's going to be executed is the second number is greater. So if you want to see that, I'll try to put a breakpoint somewhere over here. We can't change 64-bit application, la-di-da-di-da. Okay, now I put the breakpoint at the end of the else statement, so this will execute this thing and go to this bracket. Press continue. Here we're over here, nothing doing right now, but still over here. Now you can open up your console and see the second number is greater. This line of code was executed. Now this is the better alternative, putting a breakpoint at the end of some statement or even at the end of the main method, anywhere you wish. This is the better option to doing console.read line. Okay, so we got the second number is greater, and once we say, pay attention to this thing over here, once we say continue, this thing closes. That was our program, and this is our previously started program. Okay, these are the two numbers. You saw how it works. For example, if I write, now I put a breakpoint over here, and if I write 3 and 3, well, it goes into this check. Obviously this check will be true, and then we'll go into this line of code. Press F5 again. Here we go here. So, and on the next, for example, we can put a breakpoint over here, so you see this gets printed out. F5, continue. The numbers are equal. These two numbers are equal. It says it over here. So we're on this line. And when we press again, pay attention here. Press F5 again. This thing goes away. So hope you understood that. That was a check of which of two numbers is larger. I'll leave it to you to solve my riddle or task or problem or exercise or however you wish to call it, of checking whether a number is positive or negative, and if not, if it is positive, checking if it is even or odd, and if it is negative, just printing out for example, the number is negative or whatever, or damn, I think. Actually, we had one check missing over there, one condition that we didn't check, one possible situation where our code wouldn't run very properly, and that was the situation of, think about it, yeah, that was the situation of when the input is 0. So when we have the input number 0, then we obviously won't execute anything. Okay, so continuing on from here, we're going to see what we can do with multiple if-else statements. As we said a while ago, you can use a construction which is known as else if. Now, naturally, else if is just an else keyword followed by a single if statement which can have a body and another else, which else can on its own have another if, and so on and so on. In programming, and many programmers do it, they take this else if thing as a single keyword. So imagine that this is a single expression. This is sort of practical, and it is easy to imagine what happens when you use this. So what can you do with multiple if-elses? Well, you can chain up rules which you can check. For example, here's some code which gets a character. A character is what I mean. I'm not sure why it gets it as an integer, but well, it doesn't matter. So it gets a character. This should be char, really. So it gets a character and says if the character is a, that is capital A or small a, then print this is the vowel a, and this is transcribed. Okay, and then if it isn't a, so if this thing, the entire thing evaluates to false, this thing evaluates to false, well, we execute this else statement. But we execute this else statement only if, or basically we execute the else if statement only if this condition is also met. That is char ch equals c or ch equals e small. And then we execute this. If we don't have this condition met, then we'll execute the next else if, and the next else if, and the next else if. And if we don't meet anything, we can put an ending else in all other cases. The ending else here, without an if, means in all other cases which we haven't met already, execute some other code. For example, in our case, we're basically checking if some character is a vowel or not, and if it is a vowel, printing out how it should be pronounced. So if our code doesn't meet any vowels, if no else if hits, well, we can say else and console write line, this is not a vowel. For example, this is however a consonant. Or just print out some other message. For example, error, cannot pronounce non-vowel characters. Okay, or I don't know this character or something like that. Okay, let's see the multiple if-else statements. We open our Solution Explorer, and here's multiple if-else. So we read, yeah, as I said, this should be a character. We open this in full screen mode, zoom it in a bit, and we have a character. We read it from the console with console.read and convert that into a character, and then we say if the character is a, then or a small, then we print out, well, this is a, or this is I, or this is something else. So what we have here is if this condition isn't met, we check if this condition is met. If it is met, we execute this line of code. If this condition isn't met, we go to the next else if and check if this condition is met. If this condition isn't met, we go to, if it is met actually, we go here, write line vowel a, and if it is met, we will execute this and then be on our way after all the else ifs. But if it isn't met, we go on down, and then down, and then down, and if no condition is met ever in any case, well, then we just do a console write line, well, in this else here, a console write line, this is a consonant. Okay, so this would work in the following way. We execute it, enter a character, for example, E, and whoa, why does it say it is not? We have a bug. Cool. Let's see what happens. First assumption is, yeah, the first assumption is I'm using Bulgarian language and it didn't understand it. This E is an English E, not a Bulgarian E. So I switch to English language, start this thing again, enter a character E. Cool. And this is read as E. Yeah, this is read as E. Okay. If I write down O, this will say, well, this is the vowel O, and so on, and so on, and so on. If I write a consonant, for example, G, it says this is a consonant because it passes through all of these ifs, all of these conditions, and it doesn't meet any of them. No condition is met. And because no condition is met, we execute the else statement. In all other cases, we execute one of these here when it is met. Now, another thing that might be new to you, this expression contains an OR statement, that is logical OR, and this logical OR says, if this thing here is true, or this thing here is true, then the whole statement is true. So either one of them should be true, and if either one of them, no, that's not proper English. If one of them is true, if not both of them are true, but if one of them is true, or both of them are true, is also a possible solution, then execute this line of code. So one of these has to be true. And that's how we check, for example, if something is a capital or a small letter, and do the same thing in both cases. Of course, we can always write this this way. Else if, and say character equals to small a, and console write line the same thing. Console write line this same thing. Come on, Visual Studio, don't give up on me. Thanks. So, and remove this code. This is the same, whoops. This is the same thing. So, if we don't have this, but have these two, it's exactly the same thing. In this case, it won't be the same in every case. Don't make analogies every time. But in this case, or if we spread out this else if or this I or something else of these, this will be the same. So if character is A, or if character is A small, then print out vowel A. And the previous way of writing it, of implementing it, was better, because we do one single check and we do not repeat code. Avoid repeating code whenever you can. Okay, so here are our conditions, all of them, and you saw how they work. Now, feel free to pause and rewind the video if you didn't understand something fully. Now what I will show you is how else if actually works. So as I said, you could take this as if it is one keyword, and it just says if the last if thing was false, try to check this. If this is true, execute my line of code. If not, just go on. Now, how does it work? Else if actually are two keywords, and as we said, else, like if, can have a single statement after it without placing brackets. Now, what will it look like if we place brackets everywhere? Well, here's the brackets of the else. They should close somewhere down here. Put another bracket. You saw how everything indented itself to the right. Okay, so we have else. So what we have here, if it is A, then print out this is the vowel A. If not, do these checks. And as you can guess, each one of these checks can again be an else with its own body. For example, here's an opening bracket at this else, and here should be the closing bracket for that else. Here we go. This bracket over here closes with this bracket over here. So here's our next else. So if the character is E, then we print out this. If it isn't, we do the next checks. So this is nested if else. This is actually nested if else, but with additional what we had before was we didn't write the additional bracket. So if we write them again here and here at the U character, I'm not sure if U is a vowel or a consonant, and I've never been too good at English grammar, so feel free to tell me in the comments below. So this is how an if-else chain, you would probably meet this on the internet or see it in videos or other places. It would be probably called if-else chain, or multiple if-elses or else-ifs or whatever. So this is how multiple else-ifs work. So we go down one level at a time. If the character is A, okay, we print it out. If it is not A, we do some other checks. What are the other checks? Well, if it's E, we print it out. If it isn't E, well, do something else. And so on, and so on, and so on. Deeper down, deeper down, and deeper down. That's actually how things work. Now, imagining this and writing this down is difficult. So, this is the only case where you don't have to put brackets after the else. And it's even easier and recommended that you do it this way than in the way I just showed you. But I showed you that so that you knew that that's how things work. You can try it out for yourself, get a pen and paper, write it down and check it. You will see that that's exactly how it works. Okay, so that was multiple if-else statements. Now, switch case. Normally I would do a break probably somewhere here, but since this is a video and we don't have any audience and I feel like I can continue speaking, if you feel like you need a break, do it here, pause the video, and we will continue when you decide to finish your break and unpause the video or play the video. But now I'm going to continue with the switch case operation. Now, as you saw, we had in the previous example a lot of if-elses, which was a lot of extra code which we didn't need, just for checking whether a character was a vowel or a consonant from the English alphabet, and which that vowel was, and so on. Now, the switch case statement gives you the ability to make several comparisons at once. Switch case statement basically says, here's a switch, and that switch can be anything. For example, here's a switch. Okay, let's use a real switch. So this is a real switch. Please use your imagination. I'm not a very good drawer, but this is some sort of switch. A switch has several positions. It can have the position A, it can have the position B, it could have the position C. That's more like an O, isn't it? It could have the position D, it could have the position E. Yeah, my writing is as equally good as my drawing is. Okay, so this is the different positions of my switch. My switch is some variable. So this is a variable. For example, my character variable ch. And it's equal to something. Now I can say I started talking in Bulgarian. Switch. So use my character variable as a switch. This is the switch. And in the case where the character variable is equal to A, to the character A, do some code, execute some code, and we have a break over here. We'll talk about this break later on. Then we have another case with another variable, another possible value. Then we have some other code and another break over here. Well, we'll talk about that break later. And so on, and so on, and so on. So that's what we can have in a switch case statement. So switches, we say which variable is the switch, and we say what positions can that switch have. We can have the position B, the position A, the position B, and all other positions you can think of for your switch. Check that thing, and if it is exactly equal to this position, then execute this code or this code, and so on. Now, switch case statements basically evaluate to or translate to if statements which take the switch and check if it is exactly equal. So take this switch and check it if it is exactly equal to each and every single case. So this is the case A, this is the case B, and so on and so on. This is what a switch case statement evaluates to. If CH equals to A, if CH equals to B, if CH equals to C, and so on and so on. So that's how a switch case works. You can't have conditional logic because you can't write down if CH equals A or A. You can't write this down. This isn't correct code. This can't be executed. So you can't do that. This is not possible. But you can do something else, and we will discuss that later. But for now, switch case only compares directly the variable which you are switching, the switch, to the position in which it may be placed. For example, the position B. And if that if that condition is met, if that comparison is true, well, then we execute some piece of code. For example, this one. That's how switch case works. Now, the good thing of switch case is that it saves you a lot of if-else code, and it looks a bit more understandable. Here's a switch-else statement. We have a switch of a day, so we switch the day. What positions can a day have? Well, here we have defined that the day can have positions 1 through 7. And one default, we'll talk about this a little bit later on. So, positions 1 through 7, all of these over here, and each of the positions has some behavior connected to it. For example, if we switch the day, if the day is equal to 1, exactly equal to 1, then we print out Monday. If it is exactly equal to 2, we print out Tuesday, and so on and so on. If the day which we input is not a number from 1 to 7, then we fall into this default case. The default case is basically something which you can do for error handling, or for situations, or for cases which you haven't expected. So, for example, if your lever breaks, if your switch breaks, that would be a default situation because it's in no position in which you can know it. And you can say, for example, if it's a spaceship switch, you can say, man, you're in trouble, for example, as the default case. Okay, so here are the things from Monday to Sunday, print it out. Now, what do these breaks do? These breaks basically tell the compiler that its work is done. Now, in C#, these breaks are absolutely necessary at every case statement. As you can see, we do not have any brackets over here at this code. Not that we can't have, but by default we don't have. Now, this means that we have to end the case in some way, because we can have a lot of operations over here, and we need to end the case in some way. Now, in other programming languages, you can pass through several cases without any problem. For example, you can have switch day, case 1, and if case 1 is met, then you can say, for example, day equals 2, and then go on to the second line, which will execute is day 2, and execute this, and so on, and so on, and so on, and so on. That's a problem, and that's a bad way to use a switch case statement. That's a bad way to abuse a switch case statement, and it could cause you problems. So, in C# you can't do that. You can do the opposite. We'll talk about what exactly the opposite means in a moment, but right now what you need to know is you have to have a break at the end of each case line. So you have day equals 1, do something, and at the end break. Day equals 2, do something, and at the end break, and so on and so on. So always keep that in mind when you're doing switch cases. The compiler will not let you have a case in which you have code which does not end with break. Break basically means, we'll see that in the loops lecture later on, that break basically means just finish what you're doing in the current body and jump out. So jump out of here. Or if we meet the case 5, that's Friday, we break from here and continue on with the code which is after the body of the switch case statement. Okay, so that's how switch case looks like, how it works. First, this thing is evaluated. That is, this expression is evaluated, same way as an if expression will be evaluated. Then, one of the constants in the switch case statement is, if one of the constants is the same as the value of the expression, here we can have an expression which is not Boolean. That's the most important thing. In if-else statements we can only have Boolean expressions, whereas in switch case statements we can have any type of expression, as long as it can be compared to some constant variable. And in every case statement we have to have a constant variable. Like for example, here we have constants 1, 2, 4, 7 and so on. These are constant values. By the way, no is also a constant value. So if this thing is met, if one of these cases are met, the corresponding statement is executed. If no case is met, that is, no constant has the same value as the expression which was evaluated at the beginning of the switch, and if there is no default case, then the switch is basically skipped as if nothing happened. If there is a default case, the default case is executed, and after that the control is returned to whatever called the switch. So basically you have two options: either one of the constants has the same value as the expression, or no constant has the value of the expression, in which case you have two more cases, which are, if there is a default case like the one over here, this case over here, then it is executed, and then you go on to the normal execution of the code. In the other case, you just continue with the normal execution of the code. You can imagine this thing as multiple if-else statements. Basically, we can say if they equals 1, then do this code up until here. Then, you guessed it, else if they equals 2, then do the remaining code. I know it gets ugly now, but that's the situation, sorry. So, and so on, else if, until you reach the 7th case. So, else if they equal 7, then we do this code and close here. If none of these is executed, what can we do to respond to the situation? Well, we can leave an empty else, that is an else with no ifs in it, and that is actually the default case. So this default is the substitute of the last else in an if-else chain, and if it is there, well, the code which is in it will be executed. If it isn't there, like this, the code will just continue with the normal things we had after the switch case. So that's how switch case works. It's basically what an if statement is, but without all the else if and other stuff which we don't need. Okay, so that's how switch case works. Now we're going to see some example of that. We open our Solution Explorer. We have a switch statement, and there it is. We write a number in the range of 1 to 7, as we had in our example, parse that as an integer, which we will call day, and switch that day. And here's what we have: console write line Monday, and then break, write line Tuesday, and then break, write line Wednesday, and then break, and so on. If one of these is met, that is, if the expression day is also an expression, not just a variable. So if this expression is equal to 4 or 5 or 3 or anything, then the corresponding code will be executed, and then a break will be executed, which will send us directly after the switch, that is over here. And any code after this switch will be executed. So enter a number in the range 1 to 7, and then we can have a nice day at the end. So this will be executed immediately after the switch. So for example, if I write down 3, Wednesday, have a nice day. And if I write 7, we'll have Sunday, and then have a nice day, and so on and so on. If we input a number which isn't in the range of 1 through 7, we got an exception right here, because I entered a number too large to be parsed as an integer. As you probably know, integers can have up to the value 2 billion and something. I don't remember what exactly it is. So I wrote down a number which was too big, so I'll write down a smaller number, for example this one. And this says invalid day, that is, the day which you entered is not valid. That is because of our default case. The default is the ending else in an if-else chain, which is formed by these cases. You can imagine it like that. So this will always be executed if nothing else is executed, over here. So that's the default. If we don't have that default, we move it, enter a number in this range, 21 for example, we just get to have a nice day. And this thing didn't respond, which is not good code. The program should either work correctly or give a message of an error. For example, you input an invalid day. And then everything goes on as normal with the next statement after the switch case. So if you click on this bracket over here, you'll see the small little highlighting. You will notice the difference in colors over here. And go down here, you'll see that this bracket over here is also highlighted. This is the closing bracket of the if-else, of the switch case, sorry. So that's what you can do with the switch case statement. And now we'll explore the other things which you can do with the switch case statement, namely making multiple checks and executing the same code. So before that, however, we're going to see some rules about using switch. So you can't use string or a num or something like that, and any things which are keywords. Other things you cannot use. You cannot use anything which isn't a constant. For example, you cannot use you define, for example, a variable int somewhere in your code which is, for example, n. You cannot use case n. There are several reasons for that. Primarily because some case statement could change, theoretically, could change the value of n. And what do we do then? Which case statement should be executed? 2 of them, 1 of them, none of them? It's not really clear. So in C# that's just disallowed. But thankfully you can use any data type which has constant, which can be compared to constant values. For example, you can use strings, you can use enums, you can use no as a value, because no is a constant. It's not anything else. Break always exits the switch statement, the current switch case. It stays in a case statement and it exits the entire switch statement. Now in C#, what I said earlier, you can't do a fall through rule. You always have to write down break after each case statement, at the end of that case statement. So you can use, however, something different. You can't use, for example, case 1 do some code, then case 2 do some other code, and then break. But you can do something else. If you don't have any code in one case statement, you can follow it up directly with another one without a break. That means you can have, for example, in our vowel checking task, where we had if ch is equal to the character a, or ch is equal to the character small a, then do something. How do we do that with switch case? Well, we write switch, we switch our character variable, and then say in the case big A and in the case small a, write line on the console.writeLine. For example, what was it? Vowel A or something like that. So that's what you can do. And then after this break, here you're obligated to do a break. If you have, basically, here's how you can remember it. If you have some code, you're obligated to do a break. if you don't have code like here, you don't have to have a break. And in this case, this will fall through downwards. So this will basically say, if it is A, or if it is small a, do this code, execute this piece of code, and then break. That's what the switch case with several case labels does. Basically, what happens is it checks for A. If it is true, great, it executes this. If it isn't, checks for the other A, and then executes. If none of them are true, if CH doesn't match any of them, well, we just continue after the switch case statement. Okay, so that's what happens. That's how you can do, and this is called multiple labels. Basically, every case statement has a label. The constant is called a label. That small a, big A, 1, 2, 3, 4, 5, 6, 7, and other numbers, other constants, these are called labels. Basically, those are the possible values of your switch which we drew a few moments earlier. They're called labels. So you can have multiple labels corresponding to the same statement. For example, we have some animals here, and if we get a dog, well, then we say that this thing is a mammal, because dogs are mammals. If we have a crocodile or tortoise or a snake, then this is obviously a reptile. And the default case is there is no such animal, or I don't know such a kind of animal, because obviously this switch case doesn't cover all of the thousands of species on the planet. But yeah, this thing is obviously has a big mind of itself and says that if it doesn't know such an animal, then there is no such animal. You can correct that in any way you feel convenient. Okay, so what we have here is case statement. This is a single label, so we have a case with a single label. Here we have three cases with different labels. If any one of them matches the value of the expression animal, any one of these, if any one of them matches, no matter which one, then we print out reptile, and so on and so on. And now we can see a live demo of this happening. We open up multiple labels.c#, and this is our code. Okay, so what we have here is we have an animal. We read that as a string from the console, and then we switch that string. As we said, we can easily have a string in a switch case statement. And here are our dog, cat, and cow. Yeah, they're obviously animals. They're obviously mammals. By the way, I just did column selection. You do that by holding down the Alt key. That's between your control and space key, the Alt key, this key. I'm not sure if my pronunciation is correct, so I'm writing it down. So you hold down the Alt key and mark down. Okay, so dog, cat, and cow, that's our possible values for a mammal. They're all constants. This is a constant, this is a constant, this is a constant, because they're string literals. All string literals are constants. Okay, then we have basically the same thing for tortoise, snake, and crocodile, and the same thing for hawk, sparrow, and dove, which are birds, and so on. And this thing says, I don't know this animal, if it gets an animal which it doesn't know. So for example, I can start this and say cat, and it says that a cat is a mammal. Then I can say sparrow, like Jack Sparrow, and it says that this is a bird. And we can put in another case which says, for example, case Jack Sparrow, which says this is a pirate, because you know that this guy is a pirate, and he's a captain at the same time, by the way. Okay, and this thing closes, and then we have to have a water break. And if you go over here, you can see that I have I have an error, and this error says control cannot fall through from one case label to another. That is, it says that I need to have a break if I have executable code over here. So that's what it's warning me about. So break over here. And now if I compile this and start it and write down Jack Sparrow, then we'll have that pirate, and he's a captain. If I write down which one of another guy from that movie, forgot them all, case How was that captain of the Black Pearl? Don't remember. Okay, let's just say Davy Jones. I'm not sure if Davy Jones is spelled like that, but compile, start it again, and oh, Davy Jones is an animal. How sad. Davy Jones and pirate again. Okay, so there are the possible combinations of a case, but you cannot have this. You cannot have some code over here, even if it's an empty console write line. This will be an error. Cannot fall through from one case label to another. Actually, that's not the most descriptive label. That's not the most descriptive error. It should say cannot fall through from one case label to another if the case label has executable code in it. So basically, if I have this code here, I cannot do it. But if I have only comments, I can do it. I can have Jack Sparrow and Davy Jones both going to console write line. He's a pirate. As I said, why can't you have executable code? Well, because you can say, for example, animal equals crocodile, because obviously Jack is a crocodile. And you cannot not have a break, because what should happen here? Animal becomes crocodile. Should it execute this or should it go on? If it doesn't execute this, then it doesn't meet the case requirements. It should go over here. On the other hand, I can do an infinite loop like this. I can say if it's a crocodile, make it Jack Sparrow, and if it's Jack Sparrow, make it a crocodile, and this would go on forever and forever and forever, like the Curse of the Black Pearl. Like it goes on forever. So this thing will go like this and repeat itself and repeat itself and repeat itself if I have, for example, animal equals Jack Sparrow over here. So that's why you cannot have this. You can see I have an error here and an error here. You have to have breaks after any executable code. Cases are not executable code. That's how you can imagine it. This is a case. It's not actually executable code, but this is executable code, and we have a break. And if one of those meets the value of animal, of the expression animal, well, then we will execute this line. Okay, hope you understood that, and we're going to continue with the other stuff. Now, some good practices when using switch cases. Every normal situation which you expect to encounter at some point of time, you have to have a case for it. It's not obligatory. The compiler won't check every possible value which you can give to your variables. Now, that doesn't mean if you're using an integer, check all 4 billion options for an integer. No, I'm not saying that. I'm saying that every situation which you expect, that is, for example, for the days from Monday to Sunday, you have the values from 1 to 7. You have to cover all of them. That's what's expected from a switch case statement. Imagine the gearbox in your car. Imagine it having gears which don't work. That's not good, isn't it? Imagine if your engine doesn't understand some of the cases which could happen in your gearbox. You switch to 3rd gear and it just says, no, I'm not feeling like executing that right now. So you have to have a case for every normal situation, for every possible gear, for every possible day of the week, and so on and so on. If you do not have, if you get input which is different than what you expect, then meaning that, for example, if for a gear you get broken, well, that's obviously not a gear, so you say error. The car should say, whoops, pal, you broke your gearbox. Call someone to fix it, call a mechanic, whatever. Other things, put the normal case first. Now this is a bit undescriptive. What I mean is, what's the normal case for a day of the week? Well, there is no normal case. Basically, if there is no normal case, and if all cases are normal, for example, at days of the week or at gears of a car, then put them in alphabetical or numerical order, or in logical order for them. For example, days from Monday to Sunday shouldn't be ordered alphabetically, but they should be ordered by their natural order in the day, in the week. Monday is first, Tuesday is second, and so on. If it's just words, order them alphabetically. If it's words which have specific meanings, and some of them occur much more often than others. For example, if you're writing a command executing software, for example, something that opens files, copies files, and so on, well, the most often, the thing that will happen the most often is opening folders, basically navigating through folders and items. Copy and paste will be lower on the list, so you get open on the top because it's the most often situation. And if you have other types of words which don't really have any priority, for example, if you're making software which sells item from a grocery store, where you have apples and you have for example cabbage and you have beans and stuff like that, well, then you don't have a normal case. You can't say, well, more people buy beans than apples, and that's not the correct. That's not something which brings meaning to your software. What would bring meaning in that case would be order them alphabetically because in the real world, when you're ordering something which doesn't have any priority attached to it or any natural order attached to it, you just order alphabetically. For example, every dictionary, for example, is ordered alphabetically because the words in it are not ordered by their commonness, but by their alphabetically means letters. Imagine that. So I'm not going to repeat myself any more times about that. I hope you understood the logic. Making software is not about following rules, it's about following logic and doing what seems logical to you and in your case. So always try to find the most logical solution and have an open mind to other ones. Okay, so default cases, again, things that shouldn't be reached in normal circumstances. Don't use a default case for fifth gear just because people don't often use fifth gear. No, that's wrong. Use default case for broken gearbox. Okay, so that's some good practices when using the switch case statement. And now we're going to make a quick summary of what we talked about today, or more likely in this lecture, because the next lecture I'm going to record is loops, and that will be also today. So we took a look at comparison and logical operators, and we learned that they are used to compose logical conditions. Now, we didn't pay much attention to that. We didn't try out them too much in unison with conditional statements. That's because you already have an operators and expressions lecture, which is fairly deep into the material and should have showed you what is a Boolean expression, how you can calculate them, what combinations can you do. The point of this lecture was just to show how these expressions can be used in an if-else, and I hope you understood that. We talked about those kind of statements like if and if-else, and how they can be used to branch up the control flow of the program, and how you can respond to certain situations with if, and how you can respond to the opposite of those situations with an else piece. We saw how you can chain up multiple if-elses and how you can nest up if-elses in one another, and I showed you that chaining if-else statements is basically the same as nesting statements always in the else block. You can see the video back a few minutes, so you can see what we talked about there. And we saw the switch statement, which is perfectly comfortable for making a lot of checks for directly comparing situations to some variable, that is directly comparing values to an expression. So we learned that switch is basically a shorthand version of if-else statements in which comparisons are only direct and only with constants. If you want to make comparisons which are not with constants, you cannot do that with switch case. Switch case is only used for constants and for checking the value of some expression. As I gave you an example, you can imagine that as a lever, a switch, which has different positions, and you check for each one of those different positions. Okay, so that's what we talked about today. I can't ask you for questions because you're going to hear this probably when I'm already sleeping or somewhere else. So if you have any questions, we'll be happy to answer them. Our team will be happy to answer them in our YouTube channel. So if you have any questions, leave your comments below this video, and we'll try to come up with reasonable responses soon enough. Also, links to these materials will be available in the video description below, so you can check them out too. They will be links to the course name, or we'll see how we'll add them exactly, but a little poking around should get you to the materials relatively easily. So that's what was for today, and I hope you enjoyed yourself. I hope you didn't have too much problems with my English. And now, because you need to practice up what you've learned, because you can't learn programming just by watching videos. Here we have some exercises. Feel free to pause the video at any time to look at these exercises. Again, these materials will be uploaded somewhere, so you will be able to download them. But again, if you want to just see them from the video, well, here they are. Some exercises, they're not too complicated. There are a lot, actually 10 tasks. These tasks are pretty simple by themselves. Some will require some additional knowledge. You can Google around and goof around and try around and compile around and whatever you do. Wow, even more tasks. And this is the most complicated one of them, and this will probably, well, to be honest, this will be a lot of writing. So best of luck to you. That's the end of my slideshow, and see you again at the next lecture. Bye bye. And I'm stopping my recording now.